Hello everyone, welcome my dear students to India's first animated live tuition. I welcome all of you to 90 plus my tuition app. So guys, please do get ready over there. Rahul sir, over here, in front. Yes. So guys, get ready. Real quick, turn your video on. Let's check out some more numerical problems. I hope you remember the numericals which we have checked out in the previous session. So please do get ready with it. Let me know guys if you have any queries, doubts. Guys, did you have any homework in the previous session? Everyone is making faces, sir. No homework.
Okay, ma'am.
For sure.
Okay, sir, 1 minute.
Yes. Yes, just a second, guys. Fine. So guys, you can hear me, right? Give me a thumbs up to the camera. Let me see. You guys can hear me, right? Fine. Fine. Everyone is like, where is the video? Just the poster? Just the thumbnail gonna take classes? No. We'll come back. Parth is giving me a thumbs up. Fine. How many of you have done the homework? You guys had homework, right? Everyone is thinking, which homework? I gave you a question as homework. Isn't it? Real quick guys, real quick. If you have not done the homework yet, please do it. Please do it guys. If you have not done the homework yet, please do let me know. Yes, who is hand raised? Fatima, right? Fatima, what's your query in the chat box? Type it down in the chat box. Some of you are typing, I can't see you. Not just you, all of you guys can't see me. So that is there. It's okay, we are coming back. We are fixing it, don't worry. So is that, Fatima, drop your query in the chat box. Judy ma'am, please check. That was Fatima, right? Fatima Juman. Fatima, what's your doubt? Type it down in the chat box.
She did the homework.
Okay, Fatima was trying to say, sir, I did the homework, fine. I guess everyone is ready with the homework. So guys, let me know if you have any doubts, queries regarding the homework. So if you have not done the homework, do it right away. Break हो रहा है ना? Okay, there you go, guys. Now you can see me, right? Everyone, give me a thumbs up to the camera. Give me a thumbs up. Yes, sir, you're back. Fine. Everyone is not happy, I guess. Fine. So you could have stayed. You could have stood there, frozen there. We could have just heard the audio. We'll focus on the audio. We'll hear that. Fair enough. We could see you before. Now again, we can't. So now it's fine, right? Finally. Fine. So guys, who will help me with the homework? Who will help me with the homework? Yes. Mute yourself. Please do raise your hands. Who will help me with the homework? Anyone? How many of you did the homework? Be honest. How many of you did the homework? This numerical we have solved it, right?
Isaac.
Already?
Isaac.
Isaac. Yes, Isaac. Isaac, right? Isaac, Nathaniel, Joseph.
Yes, sir.
So Isaac, have you done the homework?
Yes, sir.
Fine. This was not the question, right?
Yeah, yes, sir.
Then which question?
So this question, sir.
This question was the homework.
Yeah.
Fine. So how much is the answer you got?
Sir, so I got 2 centimeters.
Come again? Size of the image. The concave mirror has focal length of 20 cm. At what distance from the mirror should a 4 cm tall object be placed so that it forms an image at a distance of 30 cm from the mirror? Also calculate the size of the image formed. So over here, what are the values given? The focal length is given 20 cm. Then a 4 cm tall object. So the height of the object is given. So what we have to find? We have to find the object distance. We need to find out the size of the image, which means the height of it, right? So the height of the image hi, and also we need to find out the u, that is the object distance. Because the image distance is given, it forms an image at a distance of 30 cm from the mirror. And in the question is mentioned, it is a concave mirror, isn't it? Fine. Thank you, Isaac. Who else want to solve this? Who else want to solve this? Ansh, right? Ansh, please raise your hands. Where is Ansh? Please do unmute yourself. Ansh is like, yes sir, we'll do it. So Ansh, this was the homework, right?
Yes, sir.
Fine. So the focal length, how will we write it? Should I write it as 20 cm or negative 20?
The negative 20.
Why it is negative?
So because according to the Cartesian sign.
Because based on the Cartesian sign convention, from the origin to the left, so it will be negative. Since in the case of concave mirror, we'll keep the object or we'll have the focus in front of the mirror, so it will be from the origin to the left, that is negative 20 cm. Fine, fair enough. Then which all values are there in the question?
Yeah, so then there's the distance from, no, wait, sorry.
Before that, we have one more value.
Yes, sir. Wait. So V plus this minus the V. So,
Yeah, before that, we have one more value in the question.
height of image equals to 4 cm.
Height of the image or object?
Height of the image.
Height of the image.
Wait. No, it's an object.
At what distance from the mirror should a 4 cm tall object be placed? So, is the height of the object HO is equal to 4 cm. Then also we have the image distance, right? V is equal to negative 30 or positive 30?
Negative 30.
Negative 30, right? Negative 30 centimeter. Because generally we'll have the image distance as negative in almost all the cases in the case of a concave mirror. So once we get the u, or once we get the object distance, we'll understand obviously we'll have the image distance as negative. Also we have to find the object distance and we have to calculate the size of the image formed. Okay, so as to calculate the size of the image formed, we need to get u, right? Object distance. How will we get u over here? Who was that? Ansh?
Yes, sir. So
What will you do for that? Come again?
So by using mirror equation.
Using the mirror equation, we can get it. So what is the mirror equation? 1 by f is equal to?
So 1 by u plus
1 by u plus 1 by v. From this, if I am taking just 1 by u on one side, the equation will become?
So 1 by f minus 1 by
1 by f minus 1 by v. So if I am taking the LCM, this equation will become?
So it will become minus 3 plus 2 by 6.
Don't apply the values too soon. So this equation we can rearrange, right? We can find the LCM, right?
Yes, sir.
So 1 into v minus 1 into f divided by v into f. Can we do that?
Yes, sir.
Okay. V minus f divided by v into f, that is 1 by u. So as to get u, we'll find the reciprocal of it, right? We'll take the reciprocal. Is it possible? Is it possible, Ansh?
Yes, yes.
Fine. V into f divided by v minus f, so that we can apply the values directly. So what is v?
So v is minus 30.
Minus 30 into minus 20 divided by? Ansh, are you there?
Yes, sir.
Minus 30 minus of minus 20. Okay? So when we do minus 30 into minus 20, how much will we get?
Minus 600.
600 divided by minus 30 minus of minus 20 means what? It will be plus, right? Minus of minus.
Plus.
Yeah. So minus 30 plus 20 will be?
So minus 10.
Minus 10. So 600 divided by minus 10. How much we will get?
So 600 divided by minus 10.
So how much we will get? The object distance if we divide it.
So minus 60.
Minus 60.
Equals as minus 60.
Minus 60 centimeters, that is the object distance. So we got the value of object distance. U as object distance. U is equal to minus 60 centimeters. Object distance U, that is minus 60. Now what we need to find out? We need to find out, calculate the size of the image formed, right? For that, what we will do?
So
We'll use which equation? Magnification equation. Very good. Thank you, Ansh. Next we'll call. Who wants to answer?
Linda.
Linda wants to answer. Okay. Linda, please do unmute yourself.
Yes, sir.
So what is the magnification formula?
Minus v by u is equal to hi by h.
Magnification M is equal to minus V by U, that is equal to HI divided by HO. Fine. So over here, which all values we have?
Minus v we have.
Minus V is there and U is there or what?
It's there.
U is there. HI is there or what?
No.
No, right? We have the value of HO. So can we take this HO to the other side?
Yes.
So from the right hand side, when it goes to the left hand side, over here it was division, right? When it goes to the other side, it will become multiplication, so that we will get the equation minus V by U into HO is equal to HI. Done and dusted. We got the equation. Apply the values. Get the answer. Fine. So Linda will be helping me out. So HI is equal to minus of V. So how much is V? We got it as? We got the value of V as minus 30, right? It is given the question itself. So minus of minus 30, because it is minus V, right? So minus of minus 30 divided by U. How much is U?
Minus 60.
Minus 60. So it is negative 60. Into HO. How much is HO?
4.
HO is 4. So we can apply this. Oh God, I've wrapped everything. Anyways. So it will be plus 4, right?
Yes.
Anyways. So over here, how will we get the answer? How will we simplify it?
You can get 60 and 4.
Can cancel 60 and 4. Okay, if we are cancelling 60 and 4, how much will we get?
15 in the denominator.
15 will be there in the denominator. Fine. So minus of minus 30 will be plus 30, right? Plus 30 divided by minus 15, right? Minus 15 in the denominator, isn't it? Now this into 4 is not required, because this 60 and 4 we have cancelled, because in 60 if we divide it with 4 we will get 15. Got it? 4 divided by 4 is 1, 60 divided by 4 is 15. That is we are dividing the numerator and denominator with 4. That is, we are cancelling it indirectly. Anyways, so 30 divided by minus 15. If we do it, how much we'll get? The height of the image. It is negative 2. Negative 2 centimeter is the height of the image. So, with respect to the height of the object, is it lesser or greater?
Lesser.
Lesser, right? So, we are getting the height of the image as negative, which means the image will be vertical and erect or real and inverted. Real and inverted, right? Why? From the Cartesian plane, based on the x-axis, if the image is in the downward direction, downward means what? Negative, right, Linda? So here we got the height of the object as negative 2. Got it? Any confusions over here? We were about to calculate the size of the image formed. So the size of the image formed is negative 2 centimeters. Fine. Thank you, Linda. So we got the answer. Anyone? Any confusions? I know I rubbed this, but the thing is, we gave it as homework, right? So you're supposed to do it. I just did it for your better, what we say, for the better understanding of it, for having a better clarity of the concept or this numeric. Everyone got it? Give me a thumbs up. Give me a thumbs up like this to the camera. Let me see that energy from you all. Don't be like, yeah, yes sir, thumbs up. Bye bye, good night. No. Let's have some positivity. Let our body feel like, okay, let's learn some numericals of reflection. You should have that energy. Let's go ahead with the next numerical. Ready? Ready, right? Fine. So let's go ahead with the next numerical. I hope you don't have any confusions regarding that particular question. Fine. There you go. Everyone give it a try. Real quick. The student has focused the image of an object of height 3 cm on a white screen using a concave mirror of focal length 12 cm. If the distance of the object from the mirror is 18 cm, find the values of the following. Distance of the image from the mirror and height of the image. So distance of the image from the mirror means the image distance. Height of the image means hi. What are the values which we have in the question? The height of the object is given, that is 3 centimeters. Then what is given? Focal length is given 12 centimeters. It is a concave mirror, it is also given. Then the distance of the object from the mirror is 18 centimeter. Object distance is also given. They feel like, okay, let me make this question very easy for everyone. So those who have designed this question, they are like, fine, let the students do it easily. No much complications. You guys have all the values applied directly to the equation. Don't forget about the sign. That is the important thing you should note over here. Everyone knows the calculation part, everyone knows the multiplication part, everyone knows to divide easy, rearrange the equation easy. But where you lack or where you lose marks is regarding the sign. You'll be putting positive instead of negative or negative instead of positive. So do remember the Cartesian sign convention. From the origin to the right positive, from the origin to the left negative. From the x-axis in the upward direction positive, from the x-axis in the downward direction negative. If the height of the image is positive, it will be a virtual and erect image. If the height of the image is negative, it will be a real and inverted image. Got it? And height of the object will always be positive, right? Will we keep the object like this? No, right? Not possible. We will not get the source of light. So obviously the height of the object HO will always be a positive value. Do remember that. Keep that in your mind. Devanarayan, any doubt? Your face looks confused. Devanarayan, yes, right over there. Yes. Devanarayan, can you please unmute yourself? Any doubt?
Not really.
Not really. Do you know how to solve this numerical?
I'm trying.
You're trying, fine. Any confusions?
No.
No, not yet. It may come soon. It will come soon, right? Fine. I don't expect. Anyways. Mugdha. Yes, unmute Mugdha. Yes, Mugdha.
For the first one, we have to find V, right?
Distance of the image from the mirror, right?
Yeah.
Distance of the distance of the image from the mirror means what? What is that particular distance? Mugda, you have to unmute yourself. Mugda is like, sir, I got answer. Bye bye. So Mugda, distance of the image from the mirror means what?
V.
V. What is V?
Yeah.
Velocity or what?
The,
What is V?
should I say the formula?
No. The denotation. What denotes V?
The image distance.
The image distance. That is the distance of the image from the mirror. Got it? So we need to find V for the first question. That is the image distance. So you know how to find out the image distance if we have the object distance and the focal length. Both values are there given the question. And don't forget about the sign, not just for Mukta and for everyone. And the question is mentioned, it is a concave mirror. So for concave mirror, how should we take the focal length? How should we consider the object distance? Please don't forget it. Pretty easy, one of the easiest numerical. Easiest. You guys will be thinking. Don't give such silly, easy, cheesy questions. So cringe, right? Everyone making faces. So questions are so cringe. Please increase the difficulty level. Mohammad Shad, done? Yes, unmute Mohammad Shad. Hi Mohammad Shad. How are you doing? Good, right? Yeah, I'm good. Thanks for asking. So Mohammad Shad, did you have school today?
Yes.
You had, right? So after school, what did you do? Any kind of hobbies, games or something you play?
Not really.
Not really. I just play some video games or what? Watch movies or anything else? Just focused on studies?
No, I was doing some.
Fine. So any tests happening in your school?
Sorry?
Any tests or exams, cycle tests or something coming up?
Yeah, we got periodic test.
Periodic test is happening. So right now it's happening or it's done? Or you're waiting for
No,
it?
It's coming. It's like in May. May.
End of this month, right? So it's gonna come soon. Fine. So Mohammad Shad, how will we find the distance of the image from the mirror? That's the first question, right?
Yes, sir.
So once you get a numerical, first thing what you'll do, you'll try to visualize it, right? Try to visualize it. Student is focusing a particular image of an object. So the object has the height of 3 centimeters. The height of the object is 3 centimeters. On a wide screen, the student is trying to focus the image. Now, the focal length of the mirror is 12 centimeters. And the distance of the object from the mirror is 18 centimeters, which means the object is kept beyond focus, right? Which means 18 centimeters is greater than 12, right? Which means the object will be kept beyond 12 centimeters. That is beyond the focus. Now, find the values of the following. We need to find out the distance of the image from the mirror. Now you got the visualization. Now let's apply the values. How will we solve it? Using which equation first? Shad, are you there? Unmute Shad. Using which equation?
Sir, I think we should use V is equal to U into F. U into F, U by F.
U into F, U by F, fine, fair enough. First we'll write the mirror formula, right?
Yes.
1 by F is equal to 1 by U plus 1 by V. From this, we'll write the equation for 1 by V, that is 1 by F minus 1 by U, isn't it? From this, we can write 1 by V is equal to U minus F divided by U into F. Then if you find the reciprocal of it, we'll get V is equal to U into F divided by U minus. That is what Shad was trying to say. So U into F, what is U?
Sir, U is 18.
U is 18 centimeter, is given the question. 18, minus 18 or plus 18?
Minus.
Negative 18, right? Negative 18 into, how much is F?
F is 12.
Negative 12 or positive 12?
Negative.
Negative 12. Why it is negative?
Because it comes in the like behind.
Behind the mirror.
No, in front of the.
In front of the mirror, from the origin to the left. So it is
Yes.
negative based on the Cartesian sign convention. Fine. So let's try to solve this. How much is minus 18 into minus 12?
Minus
18 into minus 12. Real quick.
it's
Real quick.
216.
Come again?
216. 216.
216. Sure?
Yeah.
Fine.
Yes.
So along with Shad, a lot of my students are helping me in the chat box. Sir, 216, don't calculate, easy. Fine. So minus 18 to minus 12, since it is negative and negative, we'll get positive 216. Then minus 18, minus of minus 12 means what?
It will be minus 6.
Okay, minus 18 minus of minus 12 means minus 18 plus 12, right?
Yeah.
So it will be minus 6. So 216 divided by minus 6, how much we will get? How much we will get?
Minus 36.
Minus 36 centimeter. That is the value of the image distance, negative 36 centimeter. So we got the distance of the image from the mirror. So the answer is negative 36 centimeter. Now we need to find out the height of the image, that is HI, right? We need to find out the height of the image HI. So based on the magnification formula, minus V by U is equal to HI divided by HO. Now let's ask Leora. Yes, Leora, you have a query or you want to answer?
I want to answer.
Okay, go ahead.
So we know that V is.
We know the values of which all terms over here. We know the value of V.
V, U, and H.
We know the values of V, U, and HO, right? So can we write it in terms of HI?
By U into HO.
Very good. So HO is equal to minus V by U into HO. We are taking this HO to the left hand side. So HI is equal to, how much is minus V?
So minus 36.
Minus of minus 36 divided by U. How much is it?
Minus 12.
Minus 12. Is it minus 12? U is minus 12. So your eyes like, oh, P. So U is minus
18.
minus 18. So Leora, you were focusing your siblings or any cartoons happening on TV. Focused over here, right? Fine, fine. So did you eat dark chocolate continuously, 10-15 pieces altogether? No, right? Not high on caffeine? Not yet, right? So minus of minus 36 divided by minus 18. So that will be equal to minus of minus, okay, we have into HO, right? Oh God. So Leora is gonna ask me, sir, are you really high on caffeine? No. So into HO, into HO is 3, right? Is it 3? Fine. Leora is like, sir, trust me, it's 3 for sure. Fine. So minus of minus 36 means how much? Plus 36 divided by minus 18 into 3. So if we cancel 18 and 3, how much will we get?
We'll get 2.
We'll get.
Oh, never mind. I did with 36.
You did with, okay, 36 by 18. If you do it, we'll get 2, right? Understood. That is way easy, right? Way better. Okay. Anyways, if we cancel 18 and 3, how much we will get? If I have to cancel 3 and 18, how much we will get over here in the denominator? 6 for sure. So Leora is thinking 6, right, sir? So 36 divided by negative 6. How much is it? Minus 6 centimeter. That is the value of HI. So minus 6 centimeter means what? Why is it negative? Sign convention, it is negative. What does it mean? What is the nature of the image if the height of it is negative? It's inverted. Since it is in the downward direction, it will be, the nature of the image will be just inverted. Real and inverted. I told you guys, real and inverted always together. Got it? Lovebirds together. Real and inverted. And also another pair of lovebirds are there. One more couple. Virtual and erect. So here is negative 6 centimeter. So the nature of the image will be real and inverted. Yes, Devanarayanan, you want to answer or you have a query? Go for it.
I knew this was coming. I have a doubt. I just don't know like how do you know if it's real and inverted.
Okay, you are confused. What is real and inverted?
No, like I don't know how do you know if it is real and inverted.
Okay, how do we understand it's real and inverted, right? Do you remember these particular points which we learned?
Oh yeah.
Yes, we have learned this. The height of the image is positive for virtual images. The height of the image is negative for real images. Devanarayan, now you remember? Either you might have missed this particular session which I have discussed these particular values, or else you might have forgot it. Okay, you were not like revising, or I guess. Anyways, if you didn't know this down, those who were not there and I was discussing this, you can note it down real quick. These points are important, no? Because if you don't know this, it will be very tough for you to apply. The height of the image is positive for virtual images. The height of the image is negative for real images. If the image is formed in the same side of the object, the height of the image will be negative for sure. That is in the case of concave mirror. For real images, magnification will be negative. For virtual images, magnification will be positive. Please do remember it real quick. Any doubts, queries, concerns? Yes. Who is that? Down there, who is that? Freddy. Hi, Freddy. Freddy Manuel down there in front of Marin ma'am. So guys, today we have 3 support tutors. Amrita ma'am, Marin ma'am and Judy ma'am. So Amrita ma'am is busy with a lot of things. Amrita ma'am is checking, okay, what are the things happening over here. Okay, very complex concepts. Fine. Thinking. Amrita ma'am is like, okay, a lot of students are asking doubts. Let's help them. Very dedicated over here. Guys, everyone say hi to our new support tutors. Marin ma'am and Amrita ma'am. Wave your hands. Fine. Everyone knows Judy ma'am. Okay, Judy ma'am is there. Every day she used to be there. Fine. Okay, Rihan is like, Rihan spamming the chat box or what? Rihan is like long. Say hi, hello. Hanok is asking, sir, are we going to go ahead with refraction? You want to go ahead with refraction? We'll wind up. We'll wind up the number of numericals today itself. We'll go ahead with refraction in the next session. That's it. Because what you'll be reaching, you'll be in a position where you'll be able to face all type of problems related to reflection. You'll be thorough with it. Guys, please do note down. Rahul sir, can please take down my name tag just for a second. So guys, focus on these particular points. The first one, when magnification value is 1, the size of the image and the size of the object are equal. Which means HI and HO is 1. Do you know the formula of magnification? That is M is equal to HI by HO, right? So imagine, if the height of the image is 10 and the height of the object is 10. So how much is 10 by 10? It will be 1, right? So when the magnification is 1, the size of the image and the size of the object are equal. It will be the C. So in that case, the magnification value will be 1. Now, when the magnification is more than 1, the size of the image is greater than the size of the object. The magnification value is more than 1. More than 1 means what? The size of the image will be greater, which means we'll have a greater value for HI. For example, let's apply greater value for HI and lesser value for HO. So let be 10 and 5. 10 for height of the image and 5 for height of the object. 10 by 5, if you do it, we'll get as 2, right? So the magnification will be more than 1 if the size of the image is greater than the size of the object. Everyone note it down, important. All these points are important. When magnification is less than 1, the size of the image is smaller than the size of the object. We are applying the logic to the fraction, that is HI by HO. Magnification, let's check it out. Will the magnification be less than 1 if we have the size of the image smaller than the size of the object? Let's consider the height of the image is 2 and the height of the object is 4. If you do 2 by 4, we'll get the value as 1 by 2, that is equal to 0.5, right? It will be 0.5. So 0.5 is obviously less than 1. So magnification will be less than 1 if the size of the image is smaller than the size of the object. Please don't forget it. Now, when magnification is positive, image is real and inverted. When the magnification value is negative, image is virtual and erect. Guys, always we used to think like, okay, if the height of the image is negative, it is real and inverted. If the height of the image is positive, it will be virtual and erect. But over here, with respect to magnification, it is opposite. Why? Because in the formula of magnification, it is HI by HO. First, we are considering the height of the image. So in the case of magnification, it is inversely proportional, right? So if when the magnification value is positive, we'll get the image as real and inverted. When the magnification value is negative, the image is virtual and erect. So you have to focus on the irony over here. We have learned all this, but only in the case of magnification, it comes the other way. Yes, Syed wants to show the questions first subtopic answer again. Fine. We'll go back to that. Syed, real quick. Guys, everyone, once you have done noting down this, give me a done. We need to somehow, whatever happens, even if we take some extra half an hour, we'll solve all the numericals related to reflections. Just 3 more left, I guess. Fine. Yes.
Can you explain the last?
Yes. When okay, some of you wants to know, sir. Yeah, sir, please explain last 2 points. So when magnification is positive, image is real and inverted. So for example, let's consider. For example, for a virtual image, we'll have the we'll clear this. For a virtual image, we'll have the height of the image as positive, right? Height of the image will be a positive value. So let's consider it as positive 4. Now, height of the object can't be a negative value, obviously, can't be a negative value. So we'll consider it as 4 by 2. Okay. So let's consider 4 by 2. If you do it, you will get the magnification value as 2. So over here, we got the magnification value as 2, that is a positive value. So the magnification, when the magnification is positive, we are getting the image as real and inverted. We are getting the image as real and inverted. Now, when the magnification is negative, for example, we have the magnification value as 2, negative 2. Consider we are getting the magnification value as negative 2. Anyways, so in this case, HI by HO we are doing, or minus V by U if we are doing, we can consider what we say, HI by HO, that is equal to minus V by U. In this case, consider the value of what we say, so as to get minus 2, what we have to do, the image will be virtual and erect, right? So we'll consider the value of image as positive 4 and the height of the object as negative 2. So we'll get negative 2, the magnification as negative 2. So in the first case, in this case, we need to get the image as real and inverted, right? So as to get real and inverted, we'll have the value of magnification as a positive value. For example, let's consider positive 2. And also, we can apply the values in the case of image distance and object distance as well. So please don't get confused with it. Please do note it down. When the magnification is positive, image is real and inverted. When the magnification is negative, image is virtual and erect. So guys, these points are also important. For real images, magnification will be negative. For virtual images, magnification will be positive. Okay, Haripriya is thinking the magnification will be positive for virtual images. This is inverted, negative and positive. Magnification is negative, magnification is positive. Magnification will be positive for what we say virtual and erect images. Thanks, Haripriya. Haripriya was asking about this positive and negative, right? Fine. So guys, note it down all these points. Please do correct over here, negative and positive. Please don't forget it. Haripriya, is it clear now? Now is it clear? Fine. Haripriya was like, sir, it's supposed to be negative over here. Why it's written positive? Fine. I was saying the same, but over here it's just jumble. That's it. Everyone done? Can we go ahead? Some of you were asking the second sub question. Everyone done, right? Fine. So we'll go to the second sub question. We have already done it, but who was asking that? The height of the image part, right? Are you confused with that? Who was that? Who was the second subtopic answer? Please do raise your hands. Yes, over there. Syed, can you please raise your hands? Syed. Syed, are you confused? How did we get this? Are you confused?
I just wanted to check.
You just want to check. You know how to solve this, right?
Yes, sir.
Any doubts?
No, sir.
Fine. So we can go ahead, I guess. A concave mirror produces 3 times enlarged image of an object placed at 10 cm in front of it. Calculate the radius of curvature of the mirror. So what do you think, guys? A concave mirror produces 3 times enlarged image of an object placed at 10 cm in front of it. So we are considering a concave mirror. Considering the concave mirror, the image is 3 times enlarged. So the object is placed at 10 cm in front of it. So we have the object distance over here. So it is a concave mirror, so the object distance we need to write it as negative 10 cm. And 3 times enlarged image means what? The height of the image is 3 times enlarged image. Height of the image is 3 into HO, that is 3 into height of the object. We need to calculate the radius of curvature of the mirror. Radius of curvature means what? The focal length, right? We need to calculate the value of the focal length, that is the radius of curvature of the mirror, right? If we know the focal length, can we find the radius of curvature? How? C is equal to 2 into F, or the radius of curvature R is equal to 2 into F. So we can use that. If we get the focal length value, we can find out the radius of curvature of the mirror. So a concave mirror produces 3 times enlarged image of an object, which means 3 times enlarged image of an object is the height of the image. 3 into HO is HI. So we have the value of HI, we have the value of U as minus 10 cm. So how will we find this? This is a different problem, right? Different numerical. How will we find the image distance and focal length? In the previous question we had all the values. We had the value of HO, we had the value of F and U or F and V. Now in this case, just one single value of U, remaining we are applying from the question. How will we find the answer in this case? Anyone have any idea? Everyone is thinking, sir, this is so complicated. That is why I told you. Some of you were sharing Can we go ahead with the rate fraction? No, not yet. We have a lot of problems which will confuse you. Fine. Yes, Mohammed Nurul.
We said like we have to use HI is 3HO, so like leaving 3HO by HO equals minus V by U.
3HO, okay. So, Nurul says that since HI is equal to 3 into HO, we can say using magnification formula, the magnification formula will be minus V by U is equal to HI by HO. So, from this, you're writing minus V by U is equal to 3HO by HO.
Yeah.
So, next step, in the next step, what can we do?
So it will be minus V by minus 10 equals 3HO by HO. So it will be minus V by minus 10 into HO equals 3.
Okay, minus V by minus 10 is equal to 3 into HO divided by HO, right?
Yeah.
Yeah, then from this, what can we do next?
You can do minus V by minus 10 equals 3 into HO equals 3HO.
Minus V by
Minus 10 into HO equals 3HO.
into HO is equal to 3HO. Then I don't know. Till now I help. Try it, everyone. Try it real quick.
So how you can find the value of V in HO and substitute HO?
So from this, I'll give you a hint. You can get the value of V using the formula given here. That is HI is equal to 3 into HO. Think about it. So in this step itself, you have the answer.
So is V equal to minus 30?
V is equal to?
Minus 30?
No. You have to substitute the value of V in terms of U. Yeah. Someone wants to answer. Imran, who was that? Inian. Yes, Inian. Unmute yourself.
Yes, sir. I got V as 30.
V as 30. So, Inian is saying 30 and Nurul is saying minus 30. Most of you have different values. Yes?
Can we take magnification as 3?
Can we take the magnification as 3? How?
Because the image is
3 times enlarge. How will we take the magnification as 3? Can we cancel the HO and HO in the numerator and denominator over here?
Yeah.
Can we do that?
Yes.
Yes. So minus V by U, if you do it, we'll get the value as 3 because we are cancelling this HO and HO. Nurul is like, okay, that was that. Fine. So minus V by U is equal to 3. In the next step, can we write it as minus V is equal to 3U.
Minus 30.
Minus V is equal to 3U, right?
Yeah.
So 3 into minus 10, that will be minus 30. So minus V is equal to minus 30. From this, V is equal to 30 centimeter. That is the image distance. Nurul, understood? Nurul is like, sir, I said 30, right? Just the sign got jumbled. I knew it was positive. So here, we are getting the value of V as 30. Yes, Amelia, unmute yourself real quick.
Yes, sir.
What's your doubt? Go for it.
No, sir, I don't have a doubt. I know that.
You were about to answer. Did you get the same answer, same value?
Yes, sir.
You got the same answer, right? Same value. Fine. So, how will we calculate the radius of curvature of the mirror from this? How will we find it? Amelia, are you there? Amelia, are you there? How will we find the values? Come again?
So, for the radius of, to find the radius of curvature, we have to find the focal length.
So as to find the radius of curvature, we need to find the focal length. Yes, for sure. Then for that, how will we find the focal length if we have these two values?
Using the formula of 1 by v plus 1 by u is equal to 1 by f.
1 by f is equal to 1 by v plus 1 by u. So in this, we'll substitute the value of v and u, right? So how much is v?
V is 30
How much is u?
minus 10.
Minus 10, right? So from this, we need to find out the LCM. So it will be minus 10 plus 30 divided by minus 10 into 30, right?
Yes, sir.
Yes. So can we write this as 1 by f is equal to 30 minus 10 divided by 30 into minus 10? Because it will be easy, right? Minus 10 plus 30 or 30 minus 10?
Yes, sir.
No, not at all. Oh, here, minus 10 plus 30 will be plus 20, right? Oh, here. Oh, here. Will we get the same value? Okay. Over here we'll get anyways. If we do minus 10 plus 30 or 30 minus 10, we'll get 20 itself. Fine. So we'll get 30 minus 10 as 20 divided by 30 into minus 10. If we do it, how much we'll get? 30 into minus 10, easy, right?
Minus 300.
Minus 300. So we are getting the 1 by f as 20 divided by minus 300. So we have to take the reciprocal, right? The focal length f is equal to minus 300 divided by 20. How much is it?
Minus 15.
Minus 15. Minus 15 is the focal length we are getting. So we got the value of the focal length. Now how will we find the radius of curvature?
Radius of curvature is equal to focal length into 2. So
Focal length into 2. So r is equal to 2 into negative 15. So it will be negative 30 centimeter. Fine. Fair enough.
Diane, is there any doubt?
And Ahmad, unmute yourself.
Sir, I wanted to answer, sir.
You want to answer? Fine. So how did we get the value of radius of curvature, Ayan?
Sir, minus 30, sir.
I know it's minus 30. How did we get it as minus 30?
Same answer, sir. I haven't to answer.
Come again?
I got the same answer, sir.
You got the same answer. How did we find it? How did we find the radius of curvature? Which step, which method we used?
Sir, first we had to use the formula, sir. That was
Which formula?
equal to 100 v just 1 by
Okay. Then what is it called?
sir, the mirror formula.
The mirror formula. Then so as to get the center of the radius of curvature, what did we do?
Sir, that is by 2, sir.
We have multiplied with 2. And it's like, sir, 2 into the focal length, we will get radius of curvature. First, we found the value of focal length, right? Since we know that 2 into the focal length is the radius of curvature. Since r is equal to f, we have to find out the value of focal length first. So we have applied it. Then we have found out the value. That is the value of radius of curvature is negative 30 centimeter. Any confusion, Ayan?
No, sir.
No, right? So please tilt your camera a little bit up. I need to see your face properly. Fine, fair enough. So guys, please do note it down. Let's go ahead. Everyone thought, right? Oh God, this is gonna be a tough problem. No, not at all a tough numerical. It's an easy one. Just have to apply the values directly. No confusions. So Advait is like, sir, I didn't understand. Could you explain again, please? For sure. Advait, can you please raise your hands? Let me see you. Advait. Hi, Advait. Yes. So in the question, no values are given, right? Where the question was very confusing, isn't it?
Yes, sir.
So first, the first part, the initial toughest part is to figure out the question. In the question it is mentioned, a concave mirror produces 3 times enlarged image of an object placed a 10 centimeter in front of it. So which means the height of the image is 3 times as that of the object. So do you know that HI is the height of the image?
Yes, sir.
HI is equal to 3 times of that of the object. 3 into HO is HI. So the object is placed at 10 centimeter. It is given the question itself. Can you see over here?
Yes, sir.
Fine. So we got the object distance as minus 10 centimeter. Why it is negative 10?
Sir, concave mirror.
Concave mirror. So we got it, wrote it as negative 10. So we need to calculate the radius of curvature. So as to get the radius of curvature, we need to know the focal length, right? Because radius of curvature R is equal to F. So F we don't know. Then over here the image distance is not given. We need to find out the image distance as well. But there are no values given. So we can't apply the mirror formula directly. So what are we using? We are using the magnification formula. That is minus V by U is equal to HI by HO. Can you see over here?
Yes, sir.
Do you know that? Do you know the magnification formula? No, right?
Yes, sir.
Fine. So minus V by U is equal to 3HO divided by HO. Why HO is 3HO? From the question we wrote it. HI is equal to 3 into HO. So instead of this HO, we are substituting this 3HO. We are taking this 3HO.
Sir, minus V by U is equal to the, sir, HO by HO, then what happened to HI?
Yeah, instead of HI, we are substituting this 3HO. From the question, we got HI is equal to 3 times enlarged image of an object. So HI is 3 times of HO, 3 into HO. So we are substituting this 3 into HO here instead of HI. And based on the equation, already one HO is over there itself, resting over there peacefully. So this HO is there and this 3HO we are taking. Understood? Since it was multiplication in the numerator and denominator, we are cancelling these two HOs. So only 3 is left. So minus V by U is equal to 3. So this U will go to the other side. So I'll be minus V is equal to 3U. And the value of U is given over here. So we are substituting it 3 into minus 10. That is minus V. So minus V is minus 30. So V is 30 centimeter. This negative and negative from both sides will go away. Understood the value of V? Now you understood the remaining part.
Yes, sir.
We have applied the values of V and U directly, so we'll get the focal length, and R is equal to 2 into F, so 2 into the focal length will get the radius of curvature, so that is negative 30. Clear?
Yes, sir. Thank you, sir.
Yeah. Yes, Jaron is asking, sir, can we take M is equal to minus V by U where M is equal to 3? For sure, you can do that. Over here, how did we understand M is equal to 3? From the question, since minus V by U was equal to 3 into HO divided by HO. Understood? Can we go ahead, everyone? Give me a thumbs up real quick. We need to finish this numericals today. We are going to go ahead with refraction in the next session. Fine. Do it. Try to solve this. Next one. Draw a ray diagram to show the path of the reflected ray corresponding to an incident ray which is directed towards the principal focus of a convex mirror. Mark on it the angle of incidence and the angle of reflection. So guys, this is not a numerical which you have to solve. You have to draw the ray diagram for this. Different question, I told you, right? We are going to check out all the different type of questions. Ray diagram, we have to show the path of the reflected ray corresponding to an incident ray which is directed towards the principal focus of a convex mirror. So first take the principal axis, draw the convex mirror and mark the non-reflecting side. You guys might have seen, right, when we draw a mirror, you might have seen such lines, right? What is this, spokes of porcupine? No, right? It's not the spokes of porcupine. It is the non-reflecting surface. So as to mark the non-reflecting surface, we are drawing such lines on the other side because this part will be the reflecting surface. Don't get confused with it. Some of you will be thinking, so why are we drawing such lines over there? Reflecting surface, non-reflecting surface, or the rear side of the mirror will not reflect. Rear side is the front side of the mirror. So as to mark the rear side and front side. Understood? Now first draw the principal axis. Draw the convex mirror. Then What is mentioned? A ray diagram to show the path of the reflected ray corresponding to an incident ray which is directed towards the principal focus. So it appears to fall on the principal focus, right? Of a convex mirror, mark on it the angle of incidence and the angle of reflection. So a ray is coming, an incident ray is coming. So the actual ray will reflect away, right? It will diverge. Actual ray will be like tata bye bye because it is a diverging mirror and it is directed towards the principal focus, which means it appears to fall on principal focus. Okay, imagine we'll have the center of curvature or 2f over here. So we'll get the ray diagram like this. So this is the incident ray, this is the reflected ray. So we can take the normal over here. So the normal will touch the center of curvature. So over here we can mark the angle of incidence, that is I. Over here we can mark the angle of incidence, that is R. So you'll be very confused with my artwork. So for a better clarity, I'll show the actual ray diagram. So guys, I'm just helping you just because we have the constraint of time. We need to finish the numericals today. But when you're getting such questions, don't get confused. You'll be thinking, okay, it is directed towards the principal focus, right? So it will be mentioned, it is directed towards the principal focus. So you guys will be thinking, how will we draw it? This is the answer for the previous question. Ray diagram to show the path of the reflected ray corresponding to the ray which is incident obliquely to the principal axis towards the ball of a convex mirror. So guys, this is a homework. This is a homework and this is the answer for previous question. This is the answer for previous question. Yes, who was that? Unmuted. Abhinav, any doubts?
No, sir.
So Abhinav, this is not the answer for this question. This is the answer for the previous question. Got it? Understood? If I give the answer in the previous slide itself without even trying, you guys will copy, right? So please do draw the ray diagram. Yes. Unmute Rihan. Yes, Rihan, what's your doubt? Go for it. Where is Rihan? Raise your hand.
Yes, sir, yes.
Yes, what's your doubt, Rihan?
Sir, why is there an imaginary line which is directed towards C?
This line, this is the normal.
Oh,
When you have to mark the incident ray, the angle of incidence and angle of reflection, normal should be there, right? So that is the line. Understood? Yeah. So guys, this question is homework for you. You have to draw the ray diagram to show the path of the reflected ray corresponding to the ray which is incident obliquely to the principal axis towards the pole of a convex mirror. Mark on it the angle of incidence and the angle of reflection. Real quick. Once you're done, please do let me know, guys. Let me know once you're done. Nashwa was asking, sir, can we cancel the HOs? Yes, we have cancelled the HOs. I'm seeing your message right now, Nashwa. She was like, sir, I knew this. We have to cancel HO and HO so that we'll get minus V by U is equal to 3. Very good. Nashwa understood this? This is homework, right? The previous one, got it, right? Okay, you want to see the question? Some of you wants to see the question. Guys, I'll not be giving time to write the entire question. Take a screenshot. So don't say, sir, I have screenshot in the next session. When you get time, write it down in your notebook. Leave a space over there. Write down the question once we are done with the session. So for the time being, take a screenshot. And guys, don't get confused. This imaginary line which is touching the center of curvature is the normal with respect to the angle of incidence and angle of reflection. will have a normal, right? So that is the normal. So that normal will imaginarily touch the center of curvature, or 2f. Any doubts? Anyone? Any confusions? Can I go ahead? Everyone took the screenshot? Can I go ahead? Okay. Homework question also. I'll not be giving time to write. Take a screenshot real quick. Everyone done? Took the screenshots? Fine. So there you go, next numerical, let's solve it. If an object is kept 25 centimeter in front of a concave mirror, guys, take it seriously, take it seriously. We are on the end part of reflection. Till now, if you are not able to solve the numerical, judge yourself. Try to understand, yes, I need to work on myself, I need to work on more numericals, I need to practice more. Understand where you're standing. If you feel like, okay, this is tough, you really need to work on it, you really need to practice more numericals for sure. Work on it. Don't support your jaw, Chaitra, or head. Don't rest your head on your hand. Chaitra, are you listening? Chaitra, are you listening? Don't rest your head on your hand. Your head will be like, yeah, please go on to the rest mode, don't focus. It'll result in lack of concentration.
Yes, sir.
Fine. If an unmute Chaitra. Chaitra, do you know how to solve this? Fine. If an object is kept 25 centimeter in front of a concave mirror, an image is formed 15 centimeter from the mirror, find the magnification produced. So image distance and object distance is there. So how will we find the magnification? Easy, right? Please do unmute. Whom will we call? We'll call Radia, right? Rabia. Yes. Radia. So the magnification formula, Radia, let me know.
The magnification formula is HI by HO.
HI by HO, that's it?
No, by is equals to minus V by U.
Minus V by U. Do we have the values of V and U over here? In the question. Do we have V and U? Yes, right? So how much is V?
V is minus 25.
V is negative 25. Why it is negative? Okay. V is 25 or V is 15?
15. No,
What?
it's 25.
Okay, first of all, what denotes V? Is it the object distance or image distance?
V is the image distance.
V is the image distance. So how much is the image distance marked here in the question?
15 centimeters.
An image is formed 15 centimeter from the mirror. So it is minus of?
Minus 15.
Why it is minus 15?
Because of the sign convention.
Concave mirror?
Yeah.
Mostly in front of the mirror, right? Fine. Anyways. So we'll consider an object is kept 25 centimeter in front of a concave mirror and the image is formed 15 centimeter from the mirror. Got it? Anyways. So minus of minus 15 divided by minus 25 or plus 25?
Minus.
Minus 25, object will always be kept in front of the mirror, so it will be negative. So minus of minus 15 means plus 15 divided by minus 25. How much is the magnification then?
15 divided by 25. Wait, 25 divided by 15 is.
We don't have to do that. You can cancel the numerator and denominator with 5, right? 15 divided by 5. How much? 3. Divided by?
Yeah, it's 5. The answer is 5 then.
In the numerator, 15 divided by 5. If you do it, you will get it as 3, right? 25 divided by 5 will be 5. 3 by minus 5. Or magnification m is equal to minus 3 by 5.
Yeah.
Got it? Fine. You can mute yourself. Nashwa, Fatima, did you get the same answer? Or is it different? Got the same answer, right? Minus 3 by 5. That is the magnification value. If you do this, you will get the value as negative 0.6 or something. Isn't it? Yes, negative 0.6. Fine. Any doubts? Any confusions? Anyone? No, right? Can we go ahead? Easiest problem, right? Directly you are applying the value of V and U. No confusions. It's just that you should focus on the signs. Negative, positive and all. That's it. Understood? Got it? Fine. Now the next numerical. Suppose the object distance is 3 cm in front of the mirror. Image distance is 12 cm in front of the mirror. Find the magnification. Object distance is 3 cm in front of the mirror and image distance is 12 cm. So U is in front of the mirror. Object distance, if it's in front of the mirror, it will be minus 3 cm. And the image distance is 12 cm in front of the mirror, which means V is equal to minus 12 cm. So magnification will be M is equal to minus V by U, that is equal to minus of minus 12 divided by minus 3. So minus of minus 12 means plus 12 divided by minus 3. 12 by 3, if you do it, you will get the magnification value as negative 4. So 12 by minus 3 is minus 4. So that is the magnification value. Easy, right? Direct application. Fine. So guys, just take the screenshot of the question. Understood, right? Understood how to solve it? Try it by yourself. Easiest problems. Easiest numericals. An object placed in a distance of 20 cm from a convex mirror of focal length 8 cm. Nature and the position of the image is. Who will be answering me this? Unmute Mahira, Shaz. So Mahira, please do let me know. If an object is placed at 20 cm from the convex mirror. So we are considering the convex mirror. So Mahira, where will we keep the object? In front of the mirror or behind the mirror? Mahira, are you there? Judy ma'am. Mahira, raise your hands.
Yeah.
Okay. We'll call Said. Said Ahmad on top. Yes. So Said, in the case of a convex mirror, where will we keep the object? In front of the mirror or behind the mirror?
Can you hear me?
Yes, I can hear you. In front of the mirror or behind the mirror?
Sir, convex is in front.
Yeah, not just in convex. In the case of all the mirrors, concave, convex, always the object will be in front of the mirror, right? Because the other side will not reflect. Understood? Syed, understood or what? Yes or no?
Yes, sir.
Fine. Can mute yourself. Please do respond when I'm asking. Got it?
Yes, sir. My mic is lagging also.
Okay, fine. Okay, I do understand. Fine. We'll call Mohammad Ishan down there. Ishan, don't bite your nails down there, Judy ma'am, in front of you. Yes. I told Ishan is down there and Judy ma'am is checking on top. Ishan?
Yes, sir.
Yes, Ishan. So what do you think? Over here the object will be kept in front of the mirror, right?
Yes, sir.
So object distance is 20 cm. It will be negative 20 or positive 20?
So it is negative.
Negative 20, it's written on screen. Now, what about the image distance? It's not given, right?
So
images is
Not given. Focal length is given 8 centimeter. So what will be the nature and position of the image?
nature and position will be
Over here, the focal length is given, that is 8 centimeter. So should we take it as positive or negative? Focus is on the other side, right? In the case of a convex mirror, so we have to take the focal length of convex mirror as positive. Understood, Ishan? So when we have the value of u and f, you have to use it in the equation of 1 by f is equal to 1 by u plus 1 by v. Understood, Ishan?
yes, sir.
You were focusing before, now you are not focusing. Now Ishan is like, yeah sir, I'll bite my nails. You know how to solve this?
Yes, sir.
Know it, right? So just substitute the values of u and f, then we will get v, so that you will get the position of the image. And the nature, we know it already. In the case of a convex mirror, always virtual and erect, no real and inverted. So even before getting the values, we know the nature of a convex mirror, nature of the image in the case of a convex mirror, isn't it? Ashita, Rajesh, isn't it? Any doubts? Unmute Ashita. Yes, over there in front of Merit ma'am. Left side, left end. Yes. Hi Ashita. Okay, now Ashita, Achisha. Sir, don't call my name as Ashita. So Achisha, are you getting it?
Yes.
Do you know how to solve this?
Yes, sir.
Fine. So do you know that the nature of the image will always be virtual and erect in the case of convex mirror?
Yes.
In the case of concave mirror, it will be always real and inverted, right?
Yes, sir.
Always real and inverted?
Yes.
In the case of concave mirror?
One case.
Except one single case. Fine.
And,
Yes. So if you have to write the difference between concave and convex, how will you write it?
in concave mirror, using the images formed are virtual actually.
In the case of concave mirror, the image form will be real and inverted as well as virtual and erect. But in the case of convex mirror, the images formed will always be virtual and erect. One difference. And with respect to shape, we can say concave mirror curved inwards towards the center of curvature. Convex mirror curved outwards. Concave mirror converging mirror. Convex mirror diverging mirror. Understood? So all these points you can write when it's asked to write the difference between concave and convex mirrors. So find out this. This is also a homework for you guys. Homework. Difference between concave and convex mirrors. Homework. So one question was there, ray diagram, and the next one is difference between concave and convex mirrors. Okay, minimum 4 differences. Write it down. Minimum 4 differences. Fine. So any doubts before we wind up? Any doubts? These questions we have discussed already previous exam time. Focal length of a spherical mirror is half the dash of the mirror. Focal length is half the radius of curvature, right? Of the radius of curvature. Everyone show the answers to the camera itself, okay? This is not the exam time question. This is the one which we have already discussed. I am just showing since we are in the end of reflection. Concave mirror is a mirror in which the reflecting surface is curved inwards. True or false? 1 or 2. Everyone, answer to the screen, to the camera. First option, second option. What is the right answer? True or false? True, right? Fine. Straight line connecting the pod and the center of curvature is called principal axis, main axis. It is obviously the principal axis. Now, when light is reflected from a smooth surface, the angle of incidence and angle of reflection are unequal. Is the statement true or false? First one, second one. False, everyone knows it. A real image can be projected on screen. Yes or no? Maybe. Yes, for sure, real image can be projected on a screen, whereas virtual image can't be projected on a screen. Please do keep this in your mind. Magnification is the ratio of first one, second one. Height of the image to the height of the object, or height of the object to the height of the image. First one, right? So what is this Chaitra? Chaitra is showing fifth option. Chaitra, only 2 options are there. So the first one, height of the image to the height of the object. An object is, okay, you don't have to check it. An object is placed 40 centimeter away from the concave mirror. So object distance will be negative 40, right? Everyone knows it, easy. Radius of curvature of a concave mirror is 40. What is the focal length? Focal length means R is equal to 2F. So if the radius of curvature is 40 centimeter, how much will be the focal length? From this equation we can write F is equal to R by 2. So 40 by 2 will be negative 20, right? Concave mirror, so the focal length will be negative 20. Fourth one is the right answer. Some of you showing the answer, I am so happy. Which formula gives the relation between object distance, image distance and focal length of a spherical mirror? Obviously mirror formula. It's a mirror, not lens, not the gravitational formula. Easy. Distance are measured considering the focus of the mirror. True or false? First or second? How will we measure the distance? Using the focus of the mirror or what? True or false, everyone? We'll measure the distance of the object and image from the focus or what? From where will we measure? From the pole, right? From the pole or the origin. So the statement is false. Now, a ray parallel to the principal axis after reflection will pass through. If it's parallel to the principal axis, do you remember the rules? It will pass through the principal focus. Pass through the principal focus. A ray passing through the center of curvature of a concave mirror is reflected back along the same path. It will reflect back along the same path. This statement will be true or false. Passing through the center of curvature of a concave mirror is reflected back along the same path. Do you remember the image formation? It will reflect back along the same path, right? So statement is true. Now, a ray incident obliquely to the principal axis towards a point P or pole of the mirror on the concave mirror or a convex mirror is reflected obliquely. So towards a point P or pole. So if we have a concave or a convex mirror, if it's incidenting to the pole on the convex mirror is reflected obliquely means making the same angle, right? Will it be true or false? Everyone knows it based on the image formation. So what is the nature of the image when the object is at infinity? Real and inverted, virtual and erect. The object is infinity, it will be real and inverted in the case of a concave mirror, virtual and erect in the case of convex mirror. Size of the image when the object is kept at infinity of a concave mirror. Size of it. Object is kept at infinity, concave mirror. We'll get a point sized, highly diminished image, right? So the second option is the right answer. What is the position of the image when the object is at infinity? When the object is at infinity, the image will be formed at the focus. What is the nature of the image when the object is at infinity? In the case of a concave mirror, real and inverted. In the case of convex mirror, virtual and erect. If position of the object is at dash, then the size of the image will be same as the size of the object. Focus, center of curvature. Which one? At C, right? If the object is at the center of curvature, we'll get the same size for the image. When an object is kept within the focus of a concave mirror, an enlarged image is formed behind the mirror. This image is object is kept within the focus of a concave mirror, which means we'll get the image behind the mirror, right? Within the focus means between F and P. So the nature of the image will be virtual and erect. What is the nature of the image when the object is kept between C and F? C and F means, in the case of concave mirror, concave, object between C and F, what will happen? It will be virtual and erect or real and inverted. It will be real and inverted. Fine. Can we go ahead? Okay, we'll go ahead with the exam time. Yes, we'll go ahead with the exam time. There you go, guys. Let's go ahead. Exam time. Please do minimize the Zoom application. Click on the exam tab. Submit your responses real quick. Once you're done, type done in the chat box. Easy 5 questions, right? Some of you are already sharing, sir. 10 on 10. Easy. So guys, please be true to yourself. when you're attending the exam time, when you're checking if you're checking your notebook or textbook and submitting the answers, what is the point in it? It should be beneficial for you guys, right? It is something which assesses you. So it'll not be something like the tests in your school and all. Your school will be very scared, okay, somehow we'll get the marks, no. But over here, we are assessing you guys. You need to know. Okay, where I'm standing, which all questions I know, which all questions I'm confused. Easiest 5 questions. Okay, some of you are sharing, sir, I think I misclicked an option. Your call, not on my hand. You made a mistake, you're gonna lose marks for it. Be very careful when you're submitting the responses. Some of you used to say, sir, I clicked all the right answers itself, but I got 8 on 10. You might have clicked anywhere a wrong option, even though you knew the answer. In a hurry, you might have clicked the wrong option, right? Chances are there. Everyone got 10 on 10? Fine. Everyone done? Everyone done? Show me a thumbs up. Everyone done? Show me a thumbs up to the camera. Quick, I'm waiting. From Fatima, Elena, Devananda, Meenakshi, Anakha, Hosanna, right? Hosanna Aji Chako. Yes. Everyone done? Pearl. Fun. I guess everyone is done with the exam. Some of you are like dropping emojis, sir. I got 10 on 10. Image formed by a plane mirror. Will we get a real image on a screen for using a plane mirror? No, right? So we'll get a virtual and erect image. Chaitra is like, sir, 1, 2, 3, 4. So guys, we'll get a virtual and erect image, right? Everyone is thinking, okay, in the case of plane mirror, virtual and erect. Always virtual and erect are lovebirds. So we are gonna have virtual and erect. What do you think, guys? Real and erect, real and inverted, virtual and erect, virtual and inverted. Always it will be a virtual image, it will be a virtual and erect. So the third option is the right answer. Got it? So you guys will be thinking it is inverted, right? It is not inverted as in it is upright, it is just laterally inverted. So the nature when you write, you have to write as virtual and erect. Now, a concave mirror gives real inverted and same size image if the object is placed. You know it, we have discussed it already. So you know it. At the center of curvature, if you are keeping the object, you'll get the same size for the image as well. So also can you please take down the name bar. Under which of the following conditions a concave mirror can form an image larger than the actual object? When the object is kept at a distance equal to its radius of curvature, object is kept at a distance less than its focal length, when the object is placed between focus and center of curvature, when the object is kept at a distance greater than the radius of curvature. In which case, image larger than the actual object. Between F and C, right? Do you remember the image formation of a concave mirror? Image formation of a concave mirror, do you guys remember? Concave mirror, if you are keeping the object between C and F, you'll get the enlarged image. Got it? So the answer will be the third one, that is C, when the object is placed between the focus and center of curvature. Fine. Now the next question. A full length image of a distant tall building can definitely be seen by using. Do you remember the application uses of mirrors? I told you, important. So the right answer is a convex mirror, a concave mirror, a plane mirror, both concave and plane. Which one? Archisha, I don't see any answers or responses from your side. Archisha is like plane mirror, I clicked. So in plane mirror, you'll get the tall, distant building. No, right? Archisha is saying, sir, 3. No, it is supposed to be? Anaka, which one? Anaka is like first or second, I'm confused. It is a convex mirror. Do you remember rear view mirrors? to get the entire view of the vehicles coming from behind, we'll use convex mirror, right? So as to get a full length image of a distant building, we'll use a convex mirror. Fine. So, which of the following ray diagram is correct for the ray of light incidenting on a concave mirror as shown in the figure? So, if the ray of light is incidenting parallel to the principal axis, you know the rules. If it's incidenting parallel to the principal axis, how will it reflect back? Through the same path, or through 2F or center of curvature, or within the focus and pole, or through the focus or principal focus? Which one? Everyone is like last option. That is the figure D is the right answer. Figure D is the right answer. That is, if the ray of light is incidenting parallel to the principal axis, it will pass through the principal focus. I hope you know it. I hope you remember the rules. Any doubts or queries before we wind up? Anyone? Unmute Mohammed Nurul. Yes, Nurul, what's your doubt? Raise your hand. Okay, unmute yourself. Pardon.
So for the exam, I think, so one of the options changed for me. So like the option was different for the exam.
Accidentally you clicked the wrong option, right?
No, so the option was different. So like it was like, so can you just show like the third question?
Third question.
No, not this one. Like
Okay. Third question. This one, right?
Yeah. So in the B option, so it shows like when the object is kept at the focus, like at the focus, less than the focus. So
It's
show like
it can't be like that because we schedule the exam for everyone, guys. It was the same for everyone, right?
for me it was shown like that.
No way, no chances, no rule. You might have got confused. Anyways, the system part, I can make mistakes or I can get confused, but the system won't, because we are scheduling one single exam for everyone. It will be the same for everyone. If it's the same for everyone, for you also it will be the same, because otherwise some ghost or something should come and type. You might have got confused. Got it, Nurul? So the third option is the right answer. Nurul is like, no sir, I'm sure the second option was different. It will be the same, Nurul. It can't be the different one. So here the third option is the right answer. Anyways, you know it, right? Even though the second option was different. Imagine if it's at the focus, or distance is exactly as same as the focal length. Not be possible, right? Should keep the object between focus and center of curvature. Got it?
Last option.
Okay, some of you are asking, sir, in the last question we had 5 images. The first image was the question, guys. The first image was the question. It was showing the principal axis and the incident ray. That was the question, and these are the options. Understood? Some of you are saying, sir, I had 5 images. The first one was the question. The remaining 4 was the options. Got it? Don't say, sir, I had 5 options. No, the ghost won't come. Nurul is also thinking, sir, I also had 5 options. Nurul, still any other query, or forward lower your hands? So guys, before we wind up, any doubts, queries, concerns? Not yet, right? So please do revise all the concepts of reflection. We are done with the concepts of reflection. We'll go ahead with refraction in the next session. So I'll be asking you questions. Don't forget about the homework. Please do revise. It is for you. This is the time you can decide. This is the time you can level up. When you go to the school, or when you're winding up the chapter, reflection, all the concepts should be there in your mind. If all the questions, all the concepts which we discussed today was crystal clear for you, give me a double thumbs up to the camera. Everyone, don't forget to revise, don't forget about the homework. That is mandatory. That's all for today. Thank you and have a nice day. Bye bye.